in section 2.2, we're going to talk about conditional statements today. Conditional statements are something that you guys have already seen before. You see it in advertisements everywhere. Like, for example, if you buy Tom's shoes, there's my example of a Tom shoe. then they're going to give a pair of Tom shoes to to a child in need. So they're one for one. The one for one slogan for Tom's is a conditional statement. So what we're going to do today is we're going to identify, write, and analyze the truth value of conditional statements, and then we're going to write inverse, converse, and contrapositives of conditional statements. And the reason why we're doing all this is so that we can analyze the validity or the truth of statements. So a conditional statement is traditionally in an if, something, then something format. The if part, the first part, should be your hypothesis. Your hypothesis is what comes first. In science, you guys say that it's a prediction. Those are both accurate. So if your hypothesis, then your conclusion. Your conclusion comes next. So if your conclusion is what will happen. So if you think about it in terms of the Toms, if you buy a pair of Tom shoes, then another child's going to get your Tom shoes. So what first has to happen, you have to first buy your pair of Tom shoes, and then what will happen as a result, another child will get a pair of Tom shoes. So that's an example of a conditional statement. First thing you're going to do is you're going to identify the hypothesis and conclusion of conditional statements. Number one is the easiest type of question I could give you because it's in the traditional if then format. So the hypothesis always comes on after the if. So it always is after the if. If there's an if, that's what the hypothesis is after. So this is going to be your hypothesis. You can label it with just an H. So if today's Thanksgiving, then it's going to be Thursday. So what first has to happen first? It must be Thanksgiving first, and then we know it's going to be Thursday. And that's a true statement because Thanksgiving is always on the third Thursday of November. Number two is a little bit trickier because it's not in the traditional format. It says a number is divisible by 3. That means it can be divided by 3 if it is divided by 6, if it's divisible by 6. So what first has to happen first? The hypothesis is after the word if, remember? So this is going to be your hypothesis, and that means that the rest of it has to be your conclusion. So let's think about this logically. That means this has to come first. So first, a number has to be divisible by 6. Any number that's divisible by 6. I'm going to pick lucky number 12. So can I divide 12 by 6? Yeah. Sweet. Then the conclusion is if it's first divisible by 6, then it also must be divisible by 3. So is 12 also divisible by 3? Yes. So this is also a true statement. I want you to see if you can identify the hypothesis and conclusion of number 3. The second thing we're going to be doing is we're going to be writing conditional statements. Like I said, some of these statements, like Tom's one for one slogan, isn't exactly in the if-then format. So what you're going to do is I want you to rewrite these so that they are in the traditional if something, then something. That way we can easily identify the hypothesis and the conclusion, what comes first and what comes next. So let's read number 4. It says two angles that are complementary are acute. So what that means, what we have to think about is what comes first. Well, we have to have the angles first. So if two angles are complementary, that means that they are acute. So we've done this is our hypothesis and this is our conclusion. And they aren't necessarily in that order. So let's think about this though. If two angles are complementary means add up to be 90 degrees. So here's 90 degrees. If I have two angles that add up to be 90 degrees, then they are acute. Acute means less than 90 degrees. So that means none of these can be bigger than 90 degrees. That makes sense, right? For example, if angle 1 is 30 degrees and angle 2 is 60 degrees, they add up to be 90 degrees. They're complementary. They're also both acute. They're both tiny angles. Let's see. I want to see if you guys can do 5 and 6. They're a little bit harder, but I think you can do it. Last thing we're going to do is we're going to write the converse, inverse, and contrapositive for each statement. So conditional statements actually have 4 parts. Conditional statement is traditionally the hypothesis to the conclusion, right? Now, unfortunately in math we don't use H to identify hypothesis and C to identify conclusion. What we use is P and Q, and this arrow just means then. So if P, then Q. That's your conditional statement. Converse, what you do is you flip it. Think about it like the shoes. Like, I don't know, like you flip sides of the shoes. So instead of P to Q, we're going to flip it, and now we're going to put the conclusion first, and then we're going to put the hypothesis. And it's always in the if, then format. So converse, think flip it, like you're flipping your shoes. So you're going to take whatever the conditional statement is and just flip it around. Inverse, you stay in the verse. So you actually maintain the same order. So it is your P to Q, but you negate it. So you're going to put these little tildes. The inverse, you put the nose. So if not the hypothesis, then not the conclusion. And this will make sense in a second. Finally, the contrapositive. So we flipped the statement. We put in nose. The controverse is the baby of the two, of the converse and the inverse. So the baby means you're going to flip it and you're going to put in nose. So contrapositive is if not the conclusion, then not the hypothesis. So those are three vocab words that you need to just remember these things for. And then logically equivalent statements. Logically equivalent. Equivalent means the same. Logically means, you know, logic. So logically equivalent statements mean same truth value. And I want you to highlight, circle, star. I want you to highlight conditional statement and contrapositive, because I'll explain this better in class. The conditional statement and the contrapositive are always the same truth value. Always the same. So what that means is if this conditional statement is true, then the contrapositive is going to be true. So let's go back to our Tom's example. So if you buy a pair of shoes, Tom's shoes, right? Then a student or then a kid gets Tom's, right? Gets a free pair of shoes. Cool. So this is a true statement. This is a conditional statement. If the hypothesis, then the conclusion. For a contrapositive, what you're going to do is you're going to flip it. The if and the then stay in the same spot. You're going to flip it, though, and you're going to put in nose. So the conditional statement's going to go first. So if a kid doesn't get a pair of shoes, there's my no, then that means then you didn't buy Tom's. And that's also a true statement, because these are always logically equivalent. Okay, so I know I went a little bit fast here. Here's an example. If an animal is an adult insect, then it has 6 legs. All you have to do is write the converse, inverse, and contrapositive. We'll talk about more if these statements are true in class. So converse, remember, this is your P and this is your Q. This is just your typical conditional statement. Converse, remember, you flip it. So it's actually going to be Q to P. So that means if it has 6 legs, then it is an adult insect. And you don't have to write it exactly like this. Like you could say, if an animal has 6 legs, then it is an adult insect. Like those things don't matter. But the fact that 6 legs comes first and adult insect comes last is really important. So converse, you just flip these two things. Inverse, you stay in the verse. You stay in the P to Q still. But for inverse means no. So you're going to put in nose in both parts. So you're going to just put in nose here. So if an animal isn't an adult insect, then it doesn't have 6 legs. It wouldn't make sense if then it doesn't have 6 legs. It wouldn't make sense if you said if something isn't an animal, because the main subject of this is adult insect and 6 legs. Those are the two main things, not the fact that it's an animal, really. Okay, so converse, you flip it. Inverse, you put nose, and you stay in the same order. Contrapositive, you do both of them. So you flip it, and you put the nose. So what that means is it's not Q to not P. So you're going to do both of these things. So if it doesn't have 6 legs, then it's not an adult insect. Okay, so last thing we're going to do is we're going to think about whether or not these are true or false. So let's go back to the original conditional statement. If an animal is an adult insect, then it has 6 legs. This is actually a true statement. That's the definition of an insect, is that it has 6 legs. You don't see any humans walking around with 6 legs. You don't see any cats walking around with 6 legs. Only adult insects have 6 legs. So this is true. Remember, logically equivalent, if this is a true statement, contrapositive will also be a true statement. You don't even have to think about it. It's automatically true. Let's talk about converse. If it has 6 legs, then it is an adult insect. Well, again, I told you that's an adult insect. You can think and think and think and Google if you want to, but nothing with 6 legs that's an animal that is living will be anything else but an insect. So this is also true. So that means that the inverse is also going to be true. These are logically equivalent statements. So whatever one is, the other one always has to be. And these will always be logically equivalent. So if this one would have been false, that means that the inverse would have also been false. It's really important. I wanted you to know really that these two will always be logically equivalent, and less so about the converse and inverse. All right, we learned a lot today. We're going to cover, make sure you do 8 and the reflection, and we're going to cover biconditional statements tomorrow in class. The fun fact of the video, did you know that pogonophobia is the fear of beards?